it start yet? Yes, it should. Is it? Do you see the live? Oh, type it in dot product. Did it show up? You got it? It's working? Okay, you don't need to do live anymore. All righty then. We're just directly going to go into... So this lecture will be posted on YouTube. All right, so last time we looked at Calculus 1. What was the purpose of it? Now today we're going to look at what's the purpose of Calculus 3. Okay. Can you guys see them? Yeah? All right. Functions with two or more input variables. And one output variable. In Calculus 1, we looked at one input, one output, right? Over here, we're going to look at two, like z equals so we're going to graph them on 3 axes. So x, y, z. Can you guys see the color? Okay. B. Oh, why is it so? B. Functions with several input variable and several output variables. It's kind of like this: x plus 2y z squared e to the x y z. We will learn how to interpret these vectors. So we're gonna have some. Does anybody own Surface tablet over here? Do you know how to turn off this automatic keyboard thing? Option for it? It's in the setting? Yeah. Okay, let's find the setting.
Yeah, you can also turn off tablet mode. You swipe from the right edge.
Oh. Okay.
There's a tablet mode in there. You can turn that off.
I think it is off.
On.
So it's off.
The other one is in the toolbar.
So I can't. Okay.
Yeah, move that out of the way.
Let me go to the toolbar.
Taskbar on the bottom, you should see something like the keyboard.
So over here?
And then you can turn it off.
Oh, are you talking about this right over here?
Yeah, it's somewhere on the bottom. I can't see it.
Oh, you can't see it? Oh. It doesn't show? Like this toolbar over here, or do I go to the setting? Show touch key. Oh, hopefully it will turn it off, right? Okay. Go back. Yes. Oh no, it still shows up.
Yeah, I can help you with it.
Okay, just tell me later, okay? All right. Geometric challenge of calculus 3. Graph 2D and 3D regions. Integrating over and use the right equation. That's the hardest part, knowing how to use the right equation. So deeper conceptual challenges. Find the smart way to do the integral using higher dimensional analogs. Of fundamental theorem of calculus. This time, the smart way could be either side of the equality. Remember in calculus 2, like smart side was the easier side? The underlined parts of fundamental theorem of calculus will still hold. Integral of the function f, which is the interior, equal the boundary and what is this f? Where f is a function whose derivative is f. Ooh, you guys can't see much. What? How do I increase the brightness? Nope. Did it help? No? Hold on. I know how to do that. Maybe use a different color there. Can you guys see?
That's better.
Okay. Just, I'm not going to use this color. Okay? All right. Now, three-dimensional coordinate system. Just to give you an update, they had a one confirmed case of COVID-19 in Henderson campus. So far, not on this campus yet. So it seems like we're still gonna meet in person. All right, very simple. X, Y, Z. Do you guys see that this is the negative Z? Do you guys see, can you guys visualize that? That's the negative Y, and that's the negative X. Yeah? The distance between P1 and P2 let me do it a little bit more specific. Y2, Z2. Do you guys remember that? It's very similar. Yeah, back there. Can you move the chair right in front of you so I can see your name? Or you just move it somewhere? Kiana. Yeah. Oh, move it up a little bit. I thought you have the answer. The distance formula.
Oh, the position vector?
No, what's the distance between them? What is it? What? Add it. Oh, subtract it. Yeah. Yeah. You're kind of thinking like the Pythagorean theorem. You add it and that, yeah. Was that good? Kenna? Okay. Let me see if you guys, if I could see your name. I can't see your name. Can you move your name tag over there? Bigger. Julio. I can't see your name, buddy. Yeah. Yeah, darker. Gia, yeah. Gia, Rin, and Leonard, you guys are good. Back there, can you move your name tag? Yeah. Yours too? There you go. I still can't see it. Just put it right in front of the water bottle. There you go, Alex. Okay. I can't see your name. You gotta make it darker, nice. All right. X2 minus X1 square minus Y2 minus Y1 square. Oh, sorry, plus Z2 minus Z1. Oh, Z1 square. This is the plus you're looking at. Let me see if this shows up. Does it show up? That's the plus you're thinking about, right? Yeah. When you said that, yeah. It's kind of, let's do a 3D graph of it. What the heck does that mean? I'll do my best to try to do it. Ooh, let's see. Can you guys see this? Yes, okay. All right, let's say that's your P1. That's your P2, okay? So let's figure out this. This is, that's your technically Y, right? So how do you find the Y distance? Y2 minus Y1, right? And then from there, you're going to come to this, which is the X distance. which is x2 minus x1. Do you guys see that? It's kind of hard to do 3D graph on the 2 graph. It's coming towards you. That's your x distance. And the last one, which is this height, right? Which is z2 minus z1. Now, once you get this, it's plugged in. What? Is it? No, I have a lot of batteries. In fact, I know what to do. Stop acting weird. Oh, it is full performance, yeah. All right. Now, from that, can you guys figure out what's the standard equation? Standard equation of a sphere. For the sphere of radius. Can you guys see this color? No? Radius A and center x naught, y naught, and z naught. X minus x naught square plus y minus y naught square plus z minus z naught square equal a square. Did you guys all sign up for Pearson? Yeah? This is second week. If you did not sign up for Pearson, you will be one of those few person probably will not pass this class. I don't have people failing my Cal 3. I haven't had it yet. So, yeah. So I don't get it. But in Cal 2, you guys did pretty good, right, Leonard? Yeah, in Cal 2, no. Yeah, that is true. Cal 3, everybody passes. So, all right. So let's do some definition. Ready? I found it Cal 2 because Calculus 3 you use technology. Calculus 2 you don't use as much. And converting everything to series. It's kind of like when you have to do long division using paper versus calculator. Well, they're both the same concept, but you're not using technology to do it. So calculus is kind of like that. Right? You have to explain everything in series. Do you guys remember that? And in series, it made sense why the derivative of sine is y, or the derivative of that is y, with the error and everything. So you're just going into detail of that. All right. A scalar. Have you taken physics yet over here? Who has not taken physics yet? I mean, you took no semesters of physics. Did you take the calculus physics yet? You're in calculus physics right now. Okay, there's a calculus physics. Who has not taken calculus physics yet? Oh, you're taking calculus physics. You're taking, okay. Scalar is a real number for this class. And that's the symbol for real number. A vector is an ordered pair or of real numbers. Of real numbers this is what we call a plane, so it's two-dimensional, or this one is in the 3D space. Is the set of all such pairs or triples. Oh. So here's an example of it. Which is V1, V2, V3. That vector is same as this vector. They're the same. So in terms of vector, when we look at it, we just look at the directional of it, how it moves. It could locate it on different part of the 3D space, but it's the same vector. Why it matters? Because what we'll do later on, move everything, all the vectors to the origin, and it's easier for you to calculate it when you have to deal with from the origin. Okay. Did I give you an assignment over the weekend? Any quiz? Okay. I gave you guys a lot of pop quizzes, right? Last semester?
When we were on campus, yeah.
I did, right? Okay.
But maybe not gonna do any this semester, right?
Why not? Yeah, I'm gonna give you a quiz. Especially I'm in bad mood, yeah. I'm gonna make the exam so hard. The quiz, that is. They're pretty easy to graph, right? That's the first vector. Pretty easy. Is this 1, 1, 2, 1, 2? Let's make that. It comes out like that. That's this other vector. We'll often study examples and R2 for ease, but most of the same ideas apply in the third dimension. So what's important about vectors? About vectors. Direction. And the second part is magnitude. Which is the length. This is the symbol we use for magnitude. If it's from the origin, that's what it looks like. If it's not from the origin, what's the magnitude of the vector? V1 square, V2 square, V3. I need some coffee. I had my first time ever coffee from Dutch Bro yesterday. It was really good. I see why people like it. That was pretty good. Who doesn't like Dutch Bro coffee over here? Who haven't had it yet? You guys haven't had it yet? Try it. Like, people are incredibly nice. They're just...
If you went there, guess they have alcohol.
No, they didn't have alcohol. No. They don't have alcohol in there. I discovered this new alcohol. It's called Clase Azul. You guys know about that? Yeah. That's like it's made by the villagers in Mexico with their hand. Yeah. No, I'm not kidding. Yeah, they do. It's like it supports the village. And it's really good. It's like that's what tequila should taste like, the agave taste. It's like Clase Azul. The which one I got? I got the one with the handcrafted. Expensive, yeah. Like $500 bottle. You could see their tears on the side. Like, okay, so let's look at it. What is not important? Those of you under 21, do not drink alcohol. Like, don't drink alcohol until you turn 24. You could start drinking after 24. Because your brain grows till you're 24. After that, like, you hit your max. So what's not important for I gotta learn how to turn this off. Where you draw them. Remember I told you it really doesn't matter where you draw them. You could draw it anywhere, but as long as if you could find a way to move it to the origin, it's the same. So what does vector represent? Vectors represent position and velocity. Acceleration. I have a lot of MEs over here, right? You guys are going to be doing a lot. Depends on what field you go in that ME. In a higher level of it, depends on what you do, but by then you'll use program to do it. Do they let you use SPSS yet? Do you guys know? It's a math programming where they do everything for you. Yeah, MATLAB, yeah. But if you know SPSS, you'll get job. SPSS or MATLAB. If you put that in your resume, you will not have hard time getting a job. Know those things. If you guys are going into engineering field, know those two languages. Anything. Oh my God, this is getting recorded. I'm deleting that. You guys are not gonna get that. Clase Azul sucks. Alcohol is bad. I'm Mormon, so.
Your boss is watching the stream.
They can't do anything. I'm tenured. So basically, we're looking at direction, position, acceleration, momentum, magnitude of its direction. Basically, the whole purpose of it is we want to look at some kind of object when it moves. How fast is it moving? What will happen over time? The length of it, how much force it will need to travel, so on. Force is a type of magnitude. So what about scalar? Scalars represent mass, work, etc., etc., things that just have magnitude. So what are the things you could do with vectors? You can do with vectors. Let's say you have this u vector, u1, u2, u3, and v goes v1, v2, and v3. You can add vectors. They're very trivial. Do you guys remember complex numbers? Do you guys remember complex numbers? The point of it? Think of them kind of like vectors too. Kind of, yeah, because you look at the directions of it, how it goes. You know how a complex number came to be? Like, it is said, this mathematician, I forgot his name. So, what was going on for a long period of time? So, in olden days, when you're a mathematician, you would write each other, like, letters, and you tell them, oh, can you solve this? Haha, I could solve it. And they will not share how they solve it. Yeah, but they're like, oh, I can do this. Like, can you do this? And they'll do that. So, right before algebra and so on, you had this quadratic equation, cubic equation, and so on, right? And how the heck they do the quintic equations and all that? How the heck they solve it? So when they were solving the quintic equation, they couldn't make sense. It's like, what are these numbers? What's happening? We're looking at real numbers. Think of real numbers as a line from 0 to positive to negative infinity. And all this thing going on, and it doesn't make sense. And supposedly the mathematician is walking below a bridge, and I don't know how it must have been very low, and hits his head on the bridge. And it's like, oh, there must be another dimension to it. And then he thought of it, those numbers doesn't lie over here. It has to lie on a different dimension. Thus added an extra dimension to it. Now it became a real plane, and that's when the imaginary numbers started, and he figured that out. And from that, now they could solve all these crazy equations, the quintic equations. Now, it doesn't matter how crazy the equation is. You have a formula, you plug that formula in, you could get the solution if it existed. If it didn't exist, you still understand it where it would lie. That was amazing, man. Can you imagine that, like 500-600 years ago? Thinking about imaginary numbers. All right, now scalar multiplication. I use cursive. Usually you could use scalar multiplication, they use cursive. Okay. No, just like you'll see it in the physics. In the physics, for the scalar they use cursive. Yeah,
Oh,
that
for
is
the
K.
letters themselves.
Yeah.
Like, oh, yeah.
Yeah, scalars, yeah. Cursive. Yeah,
I thought you meant like that symbol. I don't know what that is.
that's cursive K. Oh, you guys are like so not cultured, man. Yeah, that's cursive K. That is a cursive K. I'm pretty sure. Maybe I have to look at the old history book to find out. Yes. Well, well, I've seen that. Some like maybe I picked it up from the Russian or something like that. Like I'll pick things up from like.
What was the one from the other side? It's like a Russian letter.
Oh, European 7.
10-7 or what?
Yeah, European.
European 7.
Yeah. All right. So definition of you. So let's look at some definition. U is a unit vector. And we love unit vector. Why? What's the magnitude of unit vector? Yes. And calculations are often easier when we're dealing with unit vector. It's not refreshing as fast. Do you see the lag? Why is it lagging? This is Core i7. You shouldn't lag. Yeah, look, it's not refreshing as fast. What happened? What is happening? Oh, I know why. It shouldn't though. Let me take out the power supply. What am I on? Often easier with unit vector. To modify a vector to have length 1. So you could get a crazy vector, just modify it to make it into unit vector. And from that, you'll do it. We're not going to do that much in this class, but later on when you go into a different type of physics class, depends on what kind of physics class you go. What is it? Static. Oh, yeah, especially. And then, or if you look at weather movement, the weather pattern and all that, so they move everything into unit vectors. You've seen those, right? It's like, what is that? Like Superman's chest hair. It's like full of like unit vectors. Just didn't see the Superman movie? Henry Cavill? You didn't see his chest hair? That's not what you guys thinking about? Like the hair, all that? Okay, forget it. You guys have no imaginations. Can't even read my cursive K, and do not even check out Superman's hairy chest. That was very good looking. I want to have a hairy chest like him. It is.
You could just say it's a K that you invented, and we'll be like, okay.
No, it is. I'm gonna oh, it's more Kappa. There you go. That's where I picked it up from. But it's Kappa, yeah. Yeah, it is kind of cursive, yeah. I knew it. I picked it up from somewhere. The way to get 1, divide by its magnitude. So let's look at some example. You guys should know this. This is super easy. What's the magnitude of this? 3, 5, and 7. Take out your calculator. What's the magnitude of this? Chop, chop. Give me exact answer. Y'all got that, Jordy? Calculator? Can't be sitting there. Come on, guys. Maybe I should give you a calculator question. I should. Like, give you a problem that requires calculator. No, we're doing quizzes using calculator. No? No, we're like, yeah. What kind of calculator you got? CAS, right?
No, yeah, I got a CAS one.
It should work, so.
I can do the triple intervals, like try them.
Oh, you can?
Yeah, I
Okay,
want to
good.
try like a really hard one to see if it crashes.
If it's CAS, then it shouldn't crash.
I can do the triple intervals with the limits.
That's what it is. That's what, because we have to look at bounded regions. We don't look at unbounded regions. That's when it gets crazy. Because we're gonna look at like topographical map of bounded regions. Where's the fastest way to fall? Like if you jump off of a cliff, like what cliff you want to pick? So.
To die, the quickest or to die the longest?
No, to die. Obviously, you're not gonna survive because it's steep. I mean, yeah, like to survive, you wanted the least steepest one. You wanted the slowest one. So like, you have more. Well, no. If it's like super slow, like you're going like not 1 feet per hour, then that's not a death. That's just like no. Actually, that is death. Death by boredom. So yeah. 83, right? Yeah. So what would be the magnitude of it? So the unit vector for this is a unit vector. Yeah, when we go into forces and all that, yeah, that's when we look at the angles and everything. I don't know, we'll just keep it like this. My God, it's not refreshing. All right, special unit vector. Does the computer heating up is a bad sign, right? It's kind of warming up, so which is bad. Yeah, but that's the whole purpose of me getting this was it's Whoa, I can't hear you. Yeah, but we didn't even. Oh wow, we went for like 40 minutes and still heating up. Should I add like portable fan? I can feel the heat back over here. Oh my God. Oh, I know what to do. Oh, maybe I could give lecture like that. Ah. The heat was trapping it. Okay. Ah, it's heating up. It's acting weird. Hold on. Let's give it a break. Because it's doing double thing. It's mirroring it. It's almost like like you're playing video game on top of them and streaming it. Can you pause streaming? Oh, what happened? Oh wait.
You use triple intervals when you finish like fluids and stuff?
Oh, it gets crazy. But the thing is, I didn't do the physics on that part. My thing, I worked on more of algebra. So we worked on fields and rings. That's what we worked on. We didn't go into that. The only physics part that it's organizing, categorizing numbers, how they work. The only type of physics I went in, I think I explained to you guys, is like literally complex number when we dealt with singularity. And even when you deal with it, you don't have to go triple integrals.
Is that what they call it, the complex analysis?
Yeah, complex analysis, yeah. Are you in that class?
I'm going to take it.
Oh, yeah, you're gonna, like, go into the grad one. Like, when you take it the first 2 semesters, there's baby stuff. Go into the grad class. That's when it gets fun. All right, let's see. Special. Oh man. I can take this out. There you go. Maybe that's why. Let's wait a minute. How's your life? How's the protest going on? Remember the 17-year-old kid killed someone and it was out of self-defense? And then now the Trump supporter gets shot. And now it's like, oh my God, they're killing them. They're both bad. It's just the argument changes all of a sudden. One is a patriot, the other one is a terrorist. So
Let's talk about numbers instead.
what?
Let's talk about numbers instead.
Oh, what numbers?
Let's talk about linear algebra.
I converted everything into non-linear algebra.
What is abstract algebra?
That's the one. It's the field and theory and ring.
That's what that is?
Yeah, that's what it is. So that's my field. That's what I did my research
Did you ever look into quaternion?
for.
It's like Quar quaternion.
Yeah, but for what though?
And I don't know what it is. I just ran into it.
There are things I worked with it, but we dealt with real projected planes where infinity becomes an identity, which is a point now. So that's what cryptography works with. So that's what we do. So, okay,
The
computer.
graph I saw was like a sphere, and then
Yeah.
when they rotated the sphere, it became like a plane, and then they continued to rotate, and it became like a sphere.
That's what it is. So because it becomes a plane, because what it does, it goes to the edge of it, where you think it's the end of it, but no, but it becomes the new identity, which goes back to the surface, which is the identity. So when you project it, it kind of looks like sphere. But that's where the infinity is at. And then when you come back over here, and it kicks you back over there again. And it's like sphere sticking out, each of those points, so yeah. Unit vectors. UNLV don't have a lot of good algebra people. You have 1 0 0 0 1 0 and K is 0 0 1. It is often useful to write other vectors as linear combinations of I, J, and K, 3, 5, 7. Do you guys see what is this kind of look like now? What did I say a little bit earlier? Complex number. All right, so let me give you my first commandment. Ready for the first commandment? Yeah, I had a student complain about me because I made fun of religion too much. Aldo went to the president, I was like, so, and nothing happened. So I will make fun of what is dear to you, including Trump. Oh, damn it! Damn it! I'm gonna delete this video, so.
You're her boss is like, I need a drink.
Thou shall not mix up scalars and vectors. It's kind of trivial, right? Obviously, you're not going to make the mistake, but do not mix them up. It's kind of like, what is that in the Ten Commandments? Thou shalt not murder? What is that? Or kill? Kill or murder? That makes no sense. Because what if you have to kill in self-defense?
What if you have to kill an animal?
Well, I mean, animals are not equal to us. They have no soul. It makes sense. Like, so like, even including dogs. So yeah. Who said ah?
It's completely obvious, so they just decide not to include it in the Bible. Right?
Yeah. So why thou shalt not kill? Oh, he had a bone to pick. Oh, he's like, yeah, that makes no sense. Let me die, so let me get killed to prove you the point. Yeah, killing is okay then. Is that what you're getting at, Kenna? I'm good at twisting every. For everything you see in this course, oh, the Liberty University president. You guys heard it in the news? So if you go to the Liberty University, it's a Christian school. You have to sign that you cannot drink, you cannot party, you cannot mix with other races, you cannot touch, no premarital sex, no have sex outside your marriage and blah, blah, blah. And guess what he's been doing all these years? You guys know that? All of those things, partying, getting caught at a Miami the nightclub with his son, and all that. So
We know you influenced him.
could be him and I, we hung out. I'm the devil. Or maybe I bring out the truthness of people.
That's what the devil said.
Really?
I don't know.
All right, I'll stop right here.